Hi everyone, myself Dr. Balu. Currently I am working as an assistant professor in the Department of Electrical Engineering at NIT Calicut. This semester I am teaching to the B.Tech second year second semester students as a subject as Power System 1. So the entire Power System 1 is divided into 4 modules. The module 1 will cover the fundamentals of power generation and economics. Module 2 will cover the basics of transmission line, and we will see the transmission line parameter calculations, performance of the transmission line and the overhead insulators and underground cables. And the module 3 will discuss the load flow analysis, and the module 4 will discuss the distribution systems and include the load flow studies of distribution systems. So under the module 1 we will cover structure of power systems starting from the generating station, transmission system and distribution system, and sources of electrical power generation, conventional sources of power generation. We will see here the renewable and non-renewable power generations, and some of the curves, important curves and factors related to the power generation, such as load curve, load duration curve, connected load, maximum demand, demand factor. So up to we will see the base load and peak load power plant and the power generation, and we will see the power plant economics starting from the capital cost, operating cost, fuel cost, labor cost, and you will see the fixed cost and variable cost on the power plant. And we will see the tariffs: simple tariff, flat rate tariff, block rate tariff, two-part tariff and three-part tariff. And we will take the one case study and we will calculate power plant economics and the tariffs of the particular station. So in this case, I have considered the Kottagudem Thermal Power Station (KTPS) and the Srisailam Power Plant left bank and right bank. So under module 2, again it divided into the four four submodules: module 2.1, 2.2, 2.3 and 2.4. So under module 2.1 we will cover the transmission line parameters. So first we will see the different types of power transmission through the overhead transmission line and underground transmission line, and we'll see the different components associated with the overhead transmission lines: conductor, insulators, towers and poles. And we'll see the overhead line parameters. We'll calculate the overhead line resistance, overhead line inductance and overhead line capacitance, and we'll see the significance of calculating the overhead line resistance, inductance and capacitance. Then we'll move forward to the calculation of the overhead line in resistance, calculation of overhead line resistance, and you will see why the AC resistance is greater than the DC resistance of the overhead transmission line. So some of the basic concept we will discuss before discussing this overhead line resistance. There we will see the why the AC resistance is greater than DC resistance. There we will see the skin effect will play the major role, and we will see the overhead line inductance. So calculation of the inductance of the overhead transmission line. So first we will discuss with the basic concept of overhead inductance, a basic concept of inductance. Then we will calculate the flux linkages due to the internal and external fluxes of the solid single conductor. First we will see the solid conductor, then move to the standard conductor, then move to the composite standard conductor, and we will discuss the concept of geometrical mean radius and the geometrical mean distance. Then we will calculate the single phase single wire inductance, single phase two wire inductance, and the three phase three wire inductance, and the three phase four wire inductance, and they are configured in the different configurations. So flat facing, horizontal facing, circular facing, and the triangular facing with the symmetrical spacing and unsymmetrical spacing we will see. Then we will move to the bundle conductors. We'll see the calculation of the inductance by using the bundle conductor, and we'll see the conversion of single solid conductor into bundle conductor and vice versa. So under the module 2.1, again we'll move forward to the calculation of the overhead line capacitance. First we'll see the basic concept of capacitance, then we'll move to the electric field intensity or electric field and the electric potential. So we need to calculate the capacitance. We need to see that electric field intensity and charge and the electric potential. So we need to calculate the potential difference between the two plates. Then we'll move forward to the capacitance of the single phase overhead transmission line. We'll neglect the effect of earth first, then we'll consider the effect of earth. Okay, so first single phase, we'll see three phase, we'll see capacitance calculation of the overhead transmission line, single phase and three phase when neglecting the effect of earth. Then we will see the considering the effect of earth. Then these two cases we will discuss by the method of imagining the capacitance. So in the under module 2.2, we'll consider the performance of transmission line. So we'll see first classification of the overhead transmission line, medium, short, and the long transmission line. This classification we will do based on the wavelength of the transmission line, and some of the important concepts and their definitions we will see: voltage regulation, transmission efficiency, and parental effect in the transmission line. And some of the concept we will see here: the performance of the transmission lines. There we will discuss the performance of the short transmission line, performance of the medium transmission line, and performance of the long transmission line. And we will see the interpretation of the long transmission line. There we will see the each and every in terms of the hyperbolic parameters, ABCD parameters of the short, medium, and long transmission line. Under medium transmission line, again we go for the 4 classifications: receiving end capacitor model, sending end capacitor model, nominal pi, and the nominal T models. And we'll go for the rigorous analysis of the performance of the long transmission line. Then we'll calculate the equivalent ABCD parameter of the 2 transmission lines. So when 2 transmission lines are connected in series and when 2 transmission lines are connected in the parallel. So we will see the different ABCD parameter when 2 transmission lines connected in the different series and parallel combinations. Then we will see the power flow equation of the transmission line in terms of the ABCD parameters. So we will see the P and Q value in terms of the ABCD parameters, the power transferred through the overhead transmission line in terms of the ABCD parameters we see. Then we will move to the analysis of wave traveling. There especially we will see in the overhead line transmission line. So there we need to the entire transmission line we need to represent in terms of the Thevenin equivalent. Then we will do the analysis and we will calculate the short circuit voltage and open circuit voltage and short circuit current. Then we'll go for the refracted and the reflected waves. Okay, incident wave, reflected wave, and refracted wave. By we will see that in the load side, the line is terminated with the resistance, the line is terminated with the cable, the line is terminated with the bifurcated line. Then we will see the calculation of the refracted voltage and current at the load side. Under module 2.3, we will discuss the overhead line insulators. First, we will see the properties of overhead line insulators. Then we will see the selection of choice of the overhead line transmission, overhead line insulators. Then we will see the causes of failure of overhead line insulators. So then we will go for the different classification of the overhead line insulators. So pin type insulator, shackle type insulator, strain type insulator, and suspension type insulator. So then we will calculate the string efficiency of a different shackle or strain insulator. We can connect it in series to form the string. So we need to see the how the each disc in the string we need to calculate the string efficiency. So calculation of voltage distribution across the each suspension insulator in a string. We will see the mathematical derivation, so which will calculate the string efficiency, and from there we can use the each disc, the voltage across the each disc in a string we can determine. So then different methods of improving the string efficiency: by using the longer cross arms, by grading the insulators, and by employing the guard ring. So we will see the 3 different cases to improve the string efficiency. Then we will go for the sagging overhead transmission line when 2 supports are at equal levels, when 2 supports are at unequal levels, and we will consider the effect of wind and ice loading on the conductor to see the sag effect in the transmission line. And under module 2.4, we will discuss the underground cables. First we will start with the construction of the simple cable which will have the conductor. Then we will go for the insulation, then go for the metallic sheet, then up to the different layer of underground cables we will discuss. Then different insulating material which we will use for the in the underground cables. Then we'll start the classification of the underground cables based on the voltage level. So we will see the low tension, high tension, super tension, extra high tension. So based on the voltage, we can classify the different underground cables. So different types of underground cables for the 3-phase. We will see the belted underground cables, screened underground cables, and the pressure cables we will see. So the voltage level less than 66 kV, you can go for the belted underground cables and the screened underground cables. If the voltage level is above the 66 kV, you will go for the pressure cables. Then we will go for the mathematical expression to calculate the insulation resistance of the single core underground cables. Then we will go for the capacitance calculation of the underground cables. There we will consider the 3 cases. First one is we will consider the calculation of the capacitance of the single core underground cable. Then we will see the 3 core underground cables. Then we will calculate the different capacitance between the core to core and the core to earth of a three-phase underground cable. Then we'll see the dielectric stress in a single core cable. Then we'll see that due to the dielectric stress, the voltage distribution across the each layer in the underground cable, the voltage distribution is not equal. In order to make the voltage distribution equal, in order to make the voltage distribution is equal across the each layer in the underground cable, we'll go for the grading of underground cables. So first we'll see the capacitance grading, then we'll see the intership grading. So in the module 3, we'll discuss the first we'll go with the modeling of representation of the power system components. Then we'll see the advantage of the single line diagram of the impedance and reactance diagrams. Then we'll discuss the per unit systems. So here why we are going for the per unit system, what is the significance of per unit system. Then we'll convert the how to choose the base values for the per unit system, and we'll see the how to change the base value for the per unit system. Then we'll see the per unit representation of the transformer, the secondary and primary in terms of the impedance we'll see. Then at the conclusion we'll come the impedance in per unit of the primary and impedance in the per unit in the secondary, both are same. Though that is the major advantage which you are used for the per unit system to the transformers. There is no need to refer from the secondary parameter refer to the primary side and primary parameter refer to the secondary side. Then representation of the bus in a power flow or load flow analysis. So we'll see the single bus in the interconnected system. We'll take the one simple bus and we'll see the how we are going to represent the bus in a power system load flow studies. Then we'll go for the classification of the buses in the load flow studies and significance of slack reference buses. Okay, so at each bus we have the p values, key values, v values and phase angle delta. So based on the four quantities we will define the different types of buses in the load flow analysis. So we'll start with the PQ buses or the load buses, PV buses or generator buses, and the voltage controlled buses and slack bus. So we'll see the significance of the what is the slack bus, reference bus and the swing bus. Then we'll move forward to the formulation of the nodal admittance matrix. First we'll go for the properties of nodal admittance matrix, properties of the nodal impedance matrix. So here we will see what is the significance of using the nodal admittance matrix for the load flow analysis, and we'll see the what is the significance of using the nodal admittance matrix for the fault analysis. Okay, and then we'll consider the calculating the nodal admittance matrix by considering the regulating transformers. So under regulating transformer, again it has the two cases when tap changing is opposite to the given impedance and the tap changing is given in the same side of the impedance. Then we have the two we'll consider the two different cases to calculate the nodal admittance matrix by considering the regulating transformer. Then we'll move forward to the load flow methods for the transmission line. First we will see the what is the significance of need, what is the significance of iterative method for solving the load flow problems. Then we'll move forward to the Gauss-Seidel method, Newton-Raphson method, fast decoupled method, and comparison of these two methods considering the certain parameters, or we can say the certain performance parameters to compare these three methods. And the last module we'll discuss the distribution systems. So first we'll discuss the requirements of distribution system. There we will see the feeder, distributor, and the different voltage levels for the distribution system. Then design consideration in the distribution system. Then we'll classify the different types of distribution system. Then we'll compare the overhead versus underground distribution system. Then we'll see the different connections in of the distribution system, such as the radial distribution system, ring main distribution system, and the interconnected distribution system. Then we'll see the DC distribution and AC distribution, the types of the DC distributors, and we'll see the calculation of the DC distribution and the calculation of the feeder current and voltages. So similarly for the AC distribution, why AC distribution is preferred over the DC distribution system, we will discuss the what is the significance why we choose the AC distribution over the DC distributions. Okay. Then we will see the calculation of the AC distribution and the methods of solving the AC distribution problems. So these are the here we will consider the distribution system losses. So factor affecting the distribution system losses, and we will see the method for reduction of distribution system losses, integration of capacitor in the distribution system, and integration of the distributed generation in the distribution system. Then we'll go for the load flow analysis for the distribution system. There we'll consider the backward forward shift load flow method and the direct approach load method. Then we'll see the different techniques for voltage control and power factor improvement in the distribution system. So these are the whole power system 1 is divided into the 4 model: module 1, module 2, module 3, module 4. Under module 2 we have classified into the 4 sub modules to discuss the entire syllabus.